Hello, 5th grade. I am doing another screencast, and what that means is I'm recording my screen, and then you can hear me talking as we go over the lesson. So yesterday, we looked at, and today, multiplying with powers of 10. And this video is going to show us about multiplying and dividing, so we're not going to watch the whole thing, but I just wanted to look at what that means when we're multiplying by 10 to the second power, 10 to the third power. And I'm going to show you. Here we go, powers of 10 chart. I know I have it saved somewhere in my drive, but nope, that's not the one. This is the one I want. Where'd it go? Here we go. So this shows me powers of 10, and I'll put this on my Google Classroom too under extras or materials. And when we have the number 10 just by itself, it's actually like having 10 to the power of 1. That's the same thing as just 10. That means just 10 by itself. It's just one degree of powerful. So 10 to the power of 1 is just 10 on its own, and we write that as 10. 10 to the power of 2, or 10 squared is sometimes what we call it, is the same as writing 10 times 10. So this is just 10 by itself, 10 to the power of 1. 10 squared is doing 10 times 10. And my answer to 10 times 10 is 100. Now, when I'm doing powers of 10, and this only works when 10 is my base number, so when I'm doing 10 to the power of 2, 10 to the power of 8, 10 to the power of 37, I can use my exponent, my little power number over here, to tell me how many zeros are supposed to be in my answer. This power of 2 also tells me how many times I'm multiplying the same number. But when I'm working with tens, it gives me a clue to how many zeros should be in my answer. So 10 squared, well, that's a 2, and I have 2 zeros. 10 to the third, or 10 cubed, which is 10 times 10 times 10. 10 to the third, my answer is 1,000, and that has 3 zeros. Let's go down to 10 to the seventh. I'm doing 10 times 10 times 10 times 10 times 10 times 10 times 10, doing 10 7 times. But look, my 7 here, let's count the zeros. 1, 2, 3, 4, 5, 6, 7. So if I'm starting with a 10 to the power, my power tells me how many zeros come after it. So if I did 10 to the 57th power, I'd have a 1 with 57 zeros after it. That's how that works. Now let's watch the video.
Come on, everybody, do the decimal slide. Use the power of 10 to move side to side. It's a very easy dance and a very simple concept. Move the decimal like you're doing a two-step. Multiply to the right, now divide. To the left, multiply. To the right, now divide. To the left. By now I'm sure you've heard of our number system, and that it's based on the powers of 10.
What is a power of 10? Well, that's what I just showed you. 10 to the first power is just 10. 10 to the second power is 10 times 10. That's 100. 10 to the third power is 10 times 10 times 10, and that's 1,000. And if I were to do 10 to the fourth power, I'd be at 10,000. 10 to the fifth power, 100,000. 10 to the sixth power, 1,000,000.
To write a power of 10, you have two options: an expanded form or as an exponent. They say the same thing, just differently worded.
I'm going to pause it even though the song doesn't pause by itself. So there's two ways to write powers of 10. I can write the number 19 times 10 squared, which is 100. This is the same as writing 19 times 100. Or I can take my 19, this is my 19, and add 2 zeros.
So exponent to exponent. expanded is easily converted. Let's say you see an exponent of 4. That means there's 4 zeros in expanded form.
How would you write 10 to the 6th power, this means to the power of 6, in expanded form? Well, 10, and the 6 tells me 6 zeros. So which one of these answers has 6 zeros? C, 1,000,000. 1, 2, 3, 4, 5, 6, 1,000,000.
Now that we've got that covered, it's time to move. Use the power of 10 to make your decimal prove.
Okay, now here we're going to be working with not whole numbers, but decimal numbers. It's the same thing, we just have a decimal point added in.
51.274 is our example. Multiply by 10 to the second.
I don't want you to see what the answer is. 51.274 or 51 and 274 thousandths times 10 squared. 10 squared is 10 times 10, so that's 100. But when I'm working with decimals, I can use my exponent right here, my 10 to the second. That too tells me how many places I have to move my decimal point over. When I multiply, I slide it this way too. So if I take this and I move it my 2 spaces, 1, 2, I would get 5,127.4 or 5,127 and 4/10.
We can handle, you just move it to the right like you're on a dance floor to get 5,127.4. The number of times you slide is in the exponent, so 10 to the 5th means 5 times you're going to the right. So if we multiply by 0.9, it equals 90,000. All right, move.
Now, the way that works is we're starting with 10 to the 5th power times 9/10. I'm starting with times a decimal. I can add a bunch of zeros after any number in my decimal point, and it doesn't change the value. 90 hundredths is the same as 900 thousandths. I can just add zeros here. If I don't have zeros, I can count spaces where I'll add them in. So if this is my 0.9, and I have to move it 5 places over, I'm going to go 1, 2, 3, 4, 5, and my invisible decimal point would be here, which leaves me with the number 90,000. When you're practicing doing this, don't worry as much about the commas. Sometimes it can get confusing having decimals and commas. Really just get in the practice of moving that decimal point.
Right is the rule when you multiply, because the product will be larger every time.
In your own words, explain why you move the decimal point to the right when you multiply by a power of 10. So when I'm multiplying this decimal times 10 to the 3rd power, I'm really multiplying this by 1,000, because I would have 3 zeros on my number. This is the same as taking this, multiplying it by 1,000, and then doing out all the steps where I have to count decimal places over. It's so much more work to do it that way. This way, with my shortcut, I know that my 3rd power tells me to slide it over. This would be like multiplying by 10, multiplying by 100, multiplying by 1,000.
But what if it's a whole number? Where is the decimal? It's still there. It's just invisible. So 6 times 10 to the 3rd would be 6,000. Nice and easy. Come on, everybody, do the decimal slide. Use the power of 10 to move side to side. It's a very easy dance and a very simple concept. Move the decimal like you're doing a 2-step. Multiply to the right, to the right.
And we're not going to talk about dividing yet, but this is how we multiply by powers of 10. Whatever my exponent is, whatever my power number is, that's how many places I slide over.